Our material on growth economics looked at the long-run evolution of economies, how economies evolve over periods of decades, 50 years, hundreds of years. What we're going to do in this next sequence of lectures is very much shorten the time frame. We're going to look at the business cycle. The business cycle describes what happens to the macroeconomy over periods of time. Can be as short as 6 months, 1 year, 2 years, 3 years, maybe 4 or 5, but certainly no more. And it's a different sort of macroeconomic analysis that we need compared to the material that we used in growth theory, though you'll see that that material does feed into this in at least one important respect. The analysis of the business cycle essentially involves an analysis of gross domestic product and why it is that over short periods of time, the long-run upward growth that we described in our previous 2 lectures, why that sometimes seems to be reversed temporarily. Why do we get recessions? Why do these happen fairly frequently? This chart shows real per capita gross domestic product for the United States, with the shaded areas representing periods of recession. You can see from the chart that what characterises these periods of recession is a fall in per capita GDP, an interruption to that long-run upward trend that we have been talking about in our previous 2 lectures. Something happens, in other words, to the macroeconomy over these shorter periods of time, which can knock the economy off its long-run growth trajectory. And when we have recessions, we are actually talking of instances where the economy, for a temporary period, stops growing altogether and actually starts to contract. And one of the most obvious manifestations of this is what happens to the unemployment rate during these recessionary periods. And this chart demonstrates this quite clearly. During periods of recession, the unemployment rate increases and increases very, very rapidly. So I'm trying to understand labour market outcomes, trying to understand periods where people fail to find employment. We need to understand where these recessions come from. We need to understand something about the link between gross domestic product and unemployment in the short run. And the other key feature of the business cycle we're going to investigate is the implications for the rate of inflation. Whilst the previous slide showed that recessions are associated with an increase in unemployment, what this slide shows is that recessions are often associated with a decrease in the rate of inflation. And so what these 3 slides hint at is an interrelationship that appears to exist between gross domestic product, unemployment, and inflation. And it's that interrelationship that macroeconomists explore when they look at the business cycle, and it's that interrelationship that we're going to explore in the next few lectures. Let me start the analysis with a stylised representation of what is called the classical business cycle. And I'm showing you this diagram because I want to introduce some terminology to you. When we speak of the classical business cycle, we speak about a regular sequence of events that economies pass through in the short run, where we have the attainment of a peak. Now, peak is a situation where the growth of GDP reaches a maximum in the short run. GDP is at the peak of a hill, if you like. And thereafter, it enters a short period of decline. And the period of greatest decline is associated with what is called the trough. And the time interval between the peak and the trough I'm going to refer to as a contraction, or recession. I tend to use those two terms interchangeably. Once the trough is reached, the economy then turns around and real GDP starts to climb again until it reaches its next period of peak, and then we enter a new phase of contraction. Now, what this diagram illustrates is a characteristic of the real world business cycle, and that is the period of economic expansion, the period between the trough and the peak, is generally far longer than any period of economic contraction, the period between the peak and the trough. In other words, on average, the economy is growing, is expanding, but every now and then there are these short periods of contraction where that expansion is reversed, real GDP falls, and the economy can be said to shrink in size, at least in terms of economic activity, during these contractionary periods. Now, where do these contractions come from? What, if anything, can the government do in terms of macroeconomic management to avoid these contractions? What, if anything, can the government do to manage the economy out of these contractions, if they do occur, ensuring that that period of contraction is as short as it possibly can be? And what are the economic costs of the contraction, and why is this something that we should, as macroeconomists, be concerned about? Well, those are going to be the key themes of this and the next lecture. And to provide a framework, at least initially, for thinking about these issues, I want to introduce you to a very famous, though very simple piece of economic analysis known as Okun's law. Now, Okun's law takes its name from Arthur Okun, who was one of President John F. Kennedy's main economic advisors. And Okun was interested in this issue of the classical cycle, and he was interested in the issue I was talking about earlier, about the interrelationship between gross domestic product and particularly unemployment. Okun was less concerned in his analysis about any interrelationship with inflation. What he was focusing on was the interrelationship between gross domestic product and unemployment. And he's particularly interested in the issue of how costly an economic contraction might be and what benefits might therefore be conveyed to the economy if contractions could be shortened or even eliminated. And the framework that he used for his analysis was very much this idea of the classical cycle. In particular, he added one element to this classical cycle idea, and that's the upward trend in gross domestic product. So that one way of thinking about the classical business cycle is it's really about deviations of actual GDP, actual real GDP, around the upward trend. So that periods of economic boom, periods where the economy is performing very well, well, those are periods where the economy is travelling above its long-run trend. Recessions are these periods where the economy is in fact travelling below its long-run trend. Now, we've met this long-run trend before because what the long-run trend is really talking about is the level of per capita GDP that comes out of our analysis of growth economics. Growth economics, the Solo Swan model, for example, is really an analysis or a model of the economy's long-run per capita gross domestic product, which, as we've seen, is influenced by some very key structural characteristics of the economy, like the extent to which the economy puts resources away in the form of saving, like the rate of population growth, like the rate of depreciation. Those fundamental structural forces are responsible for the long-run evolution of the economy. That's not what we're interested in business cycle analysis. There are an entirely different set of forces which are relevant in the short run but not the long run. So they're relevant for the analysis of the business cycle, but these factors are not relevant for the analysis of long-run economic growth. What Okun did was a statistical analysis of the United States economy, seeing if there was an exploitable or meaningful relationship that might exist between these deviations of GDP around its long-run trend, between the business cycle, in other words, and with what was happening to unemployment, specifically with deviations of unemployment around a concept known as the natural rate of unemployment. So let me introduce some very important definitions to you, and we're going to use these definitions quite extensively. First, potential GDP. And my notation for potential GDP will be the letter Y with an asterisk next to it. Think of potential GDP as being, over some particular time period, the flow of output or GDP that is being produced when the productive resources, in particular labour and capital, are being used at what we might think of as their normal rates. Think of potential GDP as being the output that we observe in the context of long-run growth economics, for example. Potential GDP is what we would observe when there is no underutilisation of resources, when resources are fully employed, for example. But it's also what we observe when there is no overutilisation of resources. Now, underutilisation of resources, I think it's pretty clear what we mean by that. If we have unemployment, for example, then that would be a situation where labour resource is being underutilised. What do we mean by overutilisation of resources? Overutilisation of resources would be a period of unusually high economic activity, where the flow of GDP exceeded what we might expect under normal circumstances. It might be a period, for example, where firms ask their workers to work unusually high amounts of overtime hours, or where factories are kept running 24 hours, 7 days a week. Something we wouldn't ordinarily see, but results in a more than usual flow of GDP being produced. So the point about potential GDP, it's what we would observe in terms of the flow of GDP under circumstances in which resources were being neither underutilised nor overutilised. And again, I think the easiest way to think about it is that it's the economy's long-run GDP, the GDP we would expect to emerge from the fundamental structural forces that we talked about in our material on growth economics. Now let me talk a little bit about unemployment. Unemployment is one of the most complex of all macroeconomic outcomes, and it's where a lot of really important research gets undertaken in macroeconomics, and that's been true for a very long time now. One of the tricky things about unemployment as a macroeconomic concept is that there are different types of unemployment that we observe. And the different types of unemployment have different types of factors that underlie them, and also different implications for the economy. First is what is known as frictional unemployment. Frictional unemployment is the unemployment that we observe, for example, when a young person completes their schooling and is searching for their first job, or when an employee resigns from their existing job and spends a period of time searching for their new job. So it's frictional unemployment. We wouldn't, under ordinary circumstances, expect any particular individual to remain frictionally unemployed for an extended period of time. So it's associated with entry into the labour force or with movement between jobs. At any point in time in the economy, there will always be some frictionally unemployed. The second type of unemployment is known as structural unemployment. Structural unemployment is a situation where there are people in the workforce willing and able to work, searching for work, but there's a mismatch between the skills that they have and the skills that are required by employers. So you may have been trained for one particular occupation, but it turns out that that occupation, because of changes in technology, is not really something for which there is much demand. Typists, for example, find it's much more difficult for those skills to be used than what was the case 20, 30 years ago. At any point in time, there is usually some amount of structural unemployment as well. The third type of unemployment, cyclical unemployment. This is the unemployment that we observe associated with the business cycle. In particular, the unemployment that we observe when the economy is in recession. And it's cyclical unemployment we're going to be particularly concerned with in these business cycle lectures. The natural rate of unemployment, which I will notate using U for unemployment and a little asterisk. You can think of the natural rate of unemployment as being that part of the overall unemployment in the economy that is attributable to frictional and structural forces. Or to put it another way, it's that part of unemployment that is unrelated to what is happening in terms of the business cycle. At any point in time, as I mentioned, there will always be some people who are frictionally unemployed. There will always be some people who are structurally unemployed. So the natural rate of unemployment is most unlikely ever to be zero. But in the official unemployment statistics, these people are counted as being part of the overall pool of unemployed in the economy. The other way to think about the natural rate of unemployment is that if you observed an economy where the actual rate of unemployment was exactly equal to the natural rate of unemployment, then that is saying that there is no cyclical unemployment. The economy is not in a recession, for example, and the only unemployment that we're observing is that caused by frictional and structural forces. And so we can think about the following circumstances. If the economy's actual unemployment rate, now U without the asterisk stands for the overall total recorded unemployment rate, if the economy's actual unemployment rate exceeds the natural rate of unemployment, then what you must be observing is some cyclical unemployment. So we would say under these circumstances, the economy's rate of cyclical unemployment is some positive number. If, however, the actual unemployment rate were to be below the natural rate, then you would be talking about a situation in which cyclical unemployment was actually a negative number. That might sound a little strange to you. How can cyclical unemployment be a negative number? How can we even have the actual unemployment rate below the natural rate of unemployment? Think of this as being an unusual circumstance where the economy is producing above its long-run potential. It's that circumstance I was talking about before, where firms are offering lots and lots of overtime hours, where factories are being kept working 24 hours, 7 days a week. There's an enormous amount of economic activity, far more than normal, taking place. So much, in fact, that firms are actually hiring some people that they ordinarily wouldn't. So firms might be hiring a school leaver much quicker than they ordinarily would. Or firms might be hiring someone whose skills aren't exactly right, but nonetheless they can make some contribution to production. So temporarily, firms are dipping into that pool of frictional and structural unemployed and putting them to productive work. In other words, cyclical unemployment can be either positive or negative, and it's measured by the relation between actual unemployment and the natural rate of unemployment. Another important definition, this little formula here represents what is known as the output gap. Now, Y on its own represents the actual level of real GDP. And so when we talk about the output gap, we're actually talking about the difference between the actual flow of GDP and Y star, its potential flow. If that output gap turns out to be a negative number, if it's less than 0, then as you can see from the formula, that's a situation where the economy's actual GDP has fallen below its potential GDP. Think back to that classical business cycle diagram from a few slides ago. We're going to refer to this situation as a contractionary output gap. So actual GDP has fallen short of potential GDP. On the other hand, if the output gap is a positive number, so that the economy's actual GDP was in excess of its potential GDP, again, look back at the classical business cycle diagram, then we're going to refer to that as an expansionary output gap. And you'll hear me use those two terms quite a lot, contractionary output gap and expansionary output gap. Now let's bring back Arthur Okun. What Okun did was to examine data on the US economy to formulate a statistical relationship which linked what was happening to the economy's output gap with what was happening to the economy's rate of unemployment. And the relationship that Okun came up with is the one on the slide here, and this is now known as Okun's law. So the left-hand side is just the output gap relationship that I described for you a few moments ago. On the right-hand side, you can see the difference between the actual unemployment rate and the natural rate of unemployment. Remember, the natural rate of unemployment is the frictional and structural unemployment in the economy. So that term in brackets represents the economy's cyclical unemployment. If there is a difference between the actual unemployment rate and the natural rate of unemployment, then what you're observing is cyclical unemployment. And what Okun's statistical analysis showed is that those two concepts, the economy's output gap and the amount of cyclical unemployment, were related by a number which he represented by the Greek letter beta. And beta is a number that can vary across different economies, across different times in a given economy. On average, looking at the vast amount of empirical analysis that has been done on Okun's law, both for the United States and for other economies, the value most often found for beta is something around 1.5. Now, as I said, it can be different for different economies. It can even be different for the same economy at different periods of time. But roughly speaking, 1.5 seems like a reasonable number for the term beta in this Okun's law expression. So what this little expression does is provide us with a statistical link between what's happening to an economy's GDP and what is happening to unemployment in the economy. Now, there's no economic theory underlying this. That will come. This is purely what is known as an empirical relationship. In other words, the history of macroeconomic data the United States, for other countries that one might care to analyse, there does seem to be a statistical relationship that exists between the output gap and unemployment. Now, just to give you a numerical example of how this might work, suppose you had an economy that was experiencing a 2% contractionary gap. Okun's law tells us that most likely that is going to be associated with cyclical unemployment, a difference between actual unemployment and natural rate unemployment equal to 1.3. If you had an economy that was really suffering a 9% contractionary gap, for example, then according to Okun's law, well, you can expect that to be associated with cyclical unemployment of around 6%. So it's just a way of inferring from observing what's happening to output, what is happening to unemployment. It can work the other way as well. If you observe what was happening to unemployment, then you can say something about the size of the output gap. This chart gives another insight into Okun's law, this time looking at real data for the United States. The line in blue is a measure of potential GDP for the United States. The red line is actual GDP. So you can see how, on average, actual GDP follows the trend line, potential GDP, reasonably closely, but the periods of recession, like the early 1980s, the early 1990s, and the global financial period, are very obvious from this chart, periods where there is a contractionary output gap and actual GDP falls below potential GDP. Now, one of the useful things that Okun's law can be used for is to provide a measure of the economic cost of a contraction. What I'm going to do in this analysis is show you how Okun's law can give us a dollar value for how costly a contraction is. To put it another way, I'm going to show you on average how much income is lost as a result of a contraction. I'm going to use the value 1.47 for beta, as that's the value that seems to be most appropriate for recent United States data. And I'm going to look at the height of the global financial crisis, the third quarter of the year 2009. And what I'm going to do is to calculate, using Okun's law, for that particular 3-month period, the average income lost for citizens of the United States as a result of the contraction that was going on, of the contractionary output gap. So this is our information about the US economy in this particular time period. The unemployment rate in the third quarter of 2009 had reached 9.6%. In order to use Okun's law in this way, I'm going to need to know what the natural rate of unemployment is. Now, it's actually very difficult to accurately measure over any particular period of time what is happening to frictional and structural unemployment. It's very difficult as a measurement issue to accurately pin down what must be the natural rate of unemployment. I've taken as my measure of the natural rate of unemployment 4.5%. How I got that number was to look at the data, and just prior to the global financial crisis, we did in fact have a very, very close correspondence between the actual GDP in the United States and potential. They were pretty much identical going into the global financial period. So using the logic of Okun's law, it must be the case that in that period the output gap was zero, or at least very, very close to zero. So the actual unemployment observed in that period must have been very, very close to the natural rate of unemployment. And just prior to the global financial crisis, the actual unemployment rate in the United States was 4.5%. So that's why I'm using that figure as my measure of the natural rate of unemployment. The output gap, the percentage gap between actual and potential GDP, was 7.5%. So we have a contractionary output gap of 7.5%. Actual GDP, I've recorded there, $12,746.7 billion. And the data on potential GDP gives me a measure of $13,780.1 billion for potential GDP. The adult population in the United States over that period, $236 million. And so that enables me to calculate the income lost over this 3-month period, essentially by comparing the actual GDP and potential GDP, and there not been a contractionary gap. This is what we think the US economy would have produced over those 3 months. Because there was a contractionary output gap, this is what the economy actually produced over those 3 months. So the difference between the two measures lost income. Now remember our discussion of gross domestic product. Gross domestic product measures not just production but also income. So the difference between actual GDP and potential GDP is lost income. We know how many people there are in the United States, so we can calculate on average over that 3-month period, United States residents lost $4,377. Now that's a flow. That means that's the income lost over that 3-month period. If we think about how long the global financial crisis has had an impact upon actual GDP, so the contractionary gap has still not gone away. In other words, that the magnitude of the income loss would have been repeated, slightly different number of course, but the overall magnitude would have been repeated both in the 4th quarter of 2009, the 1st quarter of 2010 and so on. Then one starts to get a feel for the enormous economic damage that economic contractions do. The income loss per person in this 3-month period at the height of the global financial crisis, over $4,000. That is an extraordinary high figure and just reminds us of how costly economic recessions, contractionary output gaps can be. Okun's law reminds us how costly economic contractions, recessions can be. What we are now going to do is start thinking about some macroeconomic theory that will enable us to see where economic contractions might come from. What are the fundamental causes of these periods of economic distress? And what, if anything, can government do in terms of managing the economy to try to avoid these periods of contraction? The starting point for the theory actually involves time. It's important as we go through this material on the business cycle to appreciate that we are talking about economies as they evolve over relatively short periods of time. Periods 6 months to a year in the first instance. We'll lengthen that time period in a subsequent lecture. But for now, we're really dealing with the macroeconomy in the very, very short run. Let's just say 6 months to keep it simple. It turns out, and this was one of Keynes' main insights, or at least one of his really important insights, he made so many of course, that over these short periods of time at the aggregate level, the way economies behave is not necessarily the way that economists are used to thinking about how agents in economies behave. This is actually a really important point. I'm going to talk a little bit about microeconomics for the next few moments, because I want to make a contrast between microeconomics and macroeconomics. But it's an important contrast because grasping this point goes a very, very long way towards identifying what was one of Keynes' key insights, and indeed what is going to be one of the key foundation stones for this model of the business cycle we are then going to develop. So I want to go back to this idea of market forces and equilibrium, which we talked about in our very first lecture. The magic of markets, how price signals can coordinate decision making between consumers and producers in a way that achieves an equilibrium. And we are going to work at the microeconomic level for the next few minutes, and then I'll show you why this matters for thinking about the macroeconomy. And I want to introduce you to a very standard piece of microeconomic analysis, demand and supply analysis. If any of you have done any economics in the past, you'll find this very, very familiar. And even if you haven't done any economics before, I think these concepts are relatively easy to grasp. So I want to think about the market for a single commodity, and let's just call it ice cream. And so I have here two axes. On the horizontal axis, I'm going to record the quantity of ice cream, and on the vertical axis, I'm going to record the price of ice cream. And they are the only two pieces of information I need for this particular analysis. First, the demand for ice cream, consumers' demand for ice cream. In microeconomics, we represent that conventionally by a downward sloping line, the demand curve as it's often known. There is a great deal of sophisticated analysis that underlies the demand curve, very elegant mathematical models of why the demand curve has this negative slope can and do exist. But for our purposes, you can just think about this as something relatively intuitive, I think. What this is saying is that at relatively high prices, holding everything else constant, the demand for ice cream is relatively low. So if it cost you $10 for an ice cream, maybe you'd only ever want to purchase one ice cream. But if the price of ice cream should fall to $1, well, that's very attractive, and maybe you would purchase a great deal of ice cream. So the demand for ice cream can be represented in this framework by a negatively sloped line, which represents something which microeconomists call the law of demand. Should the price fall, the demand increases, and conversely, should the price increase, then demand will fall. So that's how we think about consumers of ice cream. What about the producers of ice cream? Their decision making is summarised by the concept of supply, and we usually work on the basis that there is a positive relationship between price and the quantity of the commodity that firms are prepared to supply. Again, there are quite elegant mathematical representations of firms' decision making, out of which emerge this positive relationship between price and quantity. And if this was a course in microeconomics, we might go through those. But for our purposes, we can just operate at a very intuitive level which simply says if suppliers of ice cream only receive a relatively low price for that ice cream, then they're unlikely to supply a great deal of it. But should market forces dictate that the price of ice cream is relatively high, then there are profit opportunities there that firms might be able to take advantage of if they supplied more ice cream to the market. So the supply of ice cream is a positively sloped line. The intuition behind that is firms' willingness to supply ice cream increases the higher is the price. All of this assumes that everything else that could possibly affect the supply decision is being held constant. How do market forces then lead to an equilibrium in this market? Well, there we have supply, and there we have demand. As you can see, there will be a coordination between those two sets of decisions at the point at which those two lines intersect, and that will be our equilibrium, concept we've spoken about briefly in the past. And let me, as notation, write the quantity of ice cream in equilibrium as Q star and the price as P star. In our first lecture, I talked about the magic of markets, how the magic of markets lead to a coordination of the decisions taken by suppliers and decisions taken by consumers, so we reach that equilibrium point. Should there be what's called an excess supply, so that a price is established where firms, ice cream sellers in this instance, want to put lots and lots of ice cream on the market, but the price is so high that consumers don't wish to purchase lots and lots of ice cream, then market forces will lead to that price falling. Should there be the opposite situation with a relatively low price, so lots and lots of demand for ice cream but not much incentive to supply a lot of ice cream, then all of those demanders, consumers, will push the price up, so that we expect in this sort of market environment that the equilibrium will be what we observe. This is the magic of markets, the way prices coordinate supply and demand decisions to achieve the equilibrium. One of the useful things that this analysis can be put to is to answer the question, what happens to that equilibrium combination of price and quantity, if there's some fundamental change in market conditions? Now, we're talking about ice cream, and one of the important determinants of the demand for ice cream is going to be the weather. So we would expect that on a hot day, there's going to be more demand for ice cream. The price needn't have changed, but simply because the weather is warmer, we would expect that the demand curve for ice cream would shift to the right. What that means in terms of this analysis is the original equilibrium is no longer an equilibrium, because that original demand curve is no longer the relevant demand curve. What matters for the market now is this new hot day demand curve. And as a result of this rightward shift in demand, market forces are going to lead to upward pressure on price, as there's this extra demand for ice cream. Higher prices call forward more supply, and we would get a new equilibrium. Let me just call that new one Q prime, and a new higher price P prime. This is very standard microeconomic analysis. It simply tells us that should some factor other than price lead to a shift in the demand curve, that's going to be reflected in a change in price and a change in quantity. In this case, on a hot day, we would expect a higher price for ice cream and more ice cream to be supplied. So let me just So our original equilibrium Q star, our new equilibrium Q prime, P star, P prime. Works the other way though on cold days. There's less demand for ice cream. The demand curve would therefore be expected to shift to the left. And market forces will once again lead to a new equilibrium being established, this time an equilibrium featuring a smaller quantity and a lower price. The point I really want you to take away from this is the role of price here. What we're seeing in effect is price adjusting to different demand conditions, with the price increasing in response to higher than normal demand, with the price decreasing in response to lower than normal demand. And as a result of that, we get this coordination of decisions between producers and consumers. We get different equilibrium points, but they are nonetheless equilibrium points. Think about this example for a moment and think about your own observation. Because now I want to ask the question, is what I've described necessarily all that accurate about the real world? Now, the last time I bought an ice cream, it cost around about $3.50. Pretty confident if I went to the store today and purchased that same ice cream, it's probably going to cost me $3.50 as well. The price hasn't changed that much. In fact, if you think about it, what this analysis suggests is that we should be seeing very frequent price changes for a commodity like ice cream. Any time a cloud passed over the sun and the temperature dropped, we would expect the demand for ice cream to fall, we would expect its price to fall. And when that cloud moved away from the sun and the temperature rose again, we would expect to see the price to increase. In reality, we don't see price changes as frequent as this type of theoretical analysis might suggest. Pretty sure the price of ice cream, say a month ago, 2 months ago, probably not all that different from the price of ice cream today, though I'm pretty sure the temperature today is probably different to what it was 1 month ago or 2 months ago. In other words, the real world is characterized by what is sometimes called price rigidity. We don't see price changes all that frequently. It's not like they never happen, of course they do, but they usually happen at fairly distinct intervals. We might see the price of ice cream in 1 year being higher than what it was the previous year. But we don't see the price of ice cream changing from day to day, from hour to hour as the temperature changes. We have price rigidity. Well, that's the market for ice cream. What on earth has that got to do with macroeconomics? Turns out it has quite a lot, because it tells us that over short periods of time, let's say less than a year, then this sort of analysis is probably not the right way to think about the ice cream market. Instead, it's almost as if the supply curve of ice cream is not this upward sloped line as conventionally drawn in microeconomic analysis. It's almost as if the supply curve is like this horizontal red line. And a horizontal line like this is associated with an unchanging price. And there's a convention in macroeconomics when we're talking about a variable whose value is unchanging, we put a little bar above the symbol for the variable to tell us that that's something that's fixed. Once we draw the supply curve like this, in other words, once we take the idea that over short periods of time, prices don't necessarily adjust in line with demand changes, that fundamentally changes our view of how markets operate. What it says is this: suppose that's normal trading conditions. Then a hot day comes along and the demand for ice cream shifts out to the right. Do we see an increase in price on that day? No. What do we see? We see a lot of ice cream being sold. It may be that the ice cream store takes on some extra staff that day in order to meet that demand. Suppose the following day the weather changes and becomes much colder and the demand curve shifts to the left. What do we see? Do we see the price fall? Not usually. What do we see? Not much ice cream gets produced that day. It may be that the ice cream store owner tells some of his or her staff, look, don't bother coming into work today, it's cold, we're not going to sell much ice cream. So the adjustments to these changed market conditions are all taking place through variations in quantity. In our microeconomic analysis of the ice cream market, the adjustments were taking place through price and then quantity. In this world, where we're taking the notion of price rigidity seriously, then the role of prices as a means of coordinating decision-making between producers and consumers, well, that role no longer makes any sense because prices are fixed in the short run. All the adjustment to changed market conditions occurs through the medium of quantity adjustments. And remember, in that microeconomic story, in that story about price and quantity adjusting, the changed demand conditions did lead not just to price changes but also to quantity changes. But in a world where prices are rigid, in a world where the price does not change in response to demand changes, where quantity is doing all of the work, if you like, then the magnitude of these quantity adjustments are much, much larger. This is a story that every macroeconomist will find very, very familiar. It's a story about, at the macroeconomic level, prices are not flexible enough to fully adjust in response to changes in demand. Therefore, over the short run, a year or less, let's say, when demand conditions in the economy change, we don't see prices changing in response. We see instead quantities changing. And what did the ice cream seller have to do when the quantity response was very large and positive? The ice cream seller had to take on more staff. What did the ice cream seller have to do when the quantity response was large but negative? The ice cream seller laid off some staff. And that is a story we can easily translate into the macroeconomic space, and that is, in fact, what John Maynard Keynes was interested in exploring in his general theory of employment, interest and money. Now, the general theory, as it's known, is an extraordinarily complex book. I would encourage you all at some point to dip into it. You won't find it easy reading, few people do, and there is still a furious debate amongst macroeconomists trying to fully understand all of the ideas that Keynes was setting out in this book. One way of thinking about the general theory is that it really is an analysis of a macroeconomy in the short run, in a world where prices do not fully adjust in response to changes in demand. Well, what happens then? And that's the macroeconomic model that we will begin to construct in a few moments. I'm now going to begin to outline for you what is sometimes called the basic Keynesian model. This is the macroeconomic version of the ice cream market I was describing to you in the previous part of the lecture. The analysis of what happens over the period of time sufficiently short so that changes in demand conditions do not lead to price changes, but to changes occurring only on the quantity side. It's called the basic Keynesian model because this is a very, very simplified version of the ideas that Keynes was putting forward in his book, The General Theory. There's a much, much more detail and much more generality in the analysis in that book than we are going to go through here. But it turns out that it's a very convenient way to get across the main themes in Keynesian economics by maintaining this assumption that prices are completely unresponsive to changes in demand conditions. Later we will relax that assumption and use a different sort of analysis. But it's actually very important, particularly when trying to understand things like government's response to the global financial crisis, to understand this basic Keynesian model. We learn a great deal about the nature of the business cycle and how macroeconomists think about the business cycle from this type of analysis. Going to begin with some definitions and introduce you to a very important concept, the concept of macroeconomic equilibrium. But we need to learn the language of this model first. The key element to this model is a concept known as planned aggregate expenditure, which I'll usually abbreviate to PAE. This is an instance where a term in economics means exactly what it says. It's the flow of total planned spending in aggregate on final goods and services. The key word is this one, planned. This is what agents in the economy are planning to spend. It's not necessarily what they end up actually spending, which will be one of our key themes. But this is the spending plans of agents in the economy. What are they spending on? Final goods and services. Now we're going to analyse planned spending in a very organised fashion. We're going to go back to something we've talked about in a previous lecture, and that is how macroeconomists tend to split the economy up into distinct sectors. So we're going to consider separately planned spending by the household sector, remember that's you and I, firms, so the businesses who actually produce output, the government and the foreign sectors, in particular people living in other countries who purchase exports. Aggregate expenditure, on the other hand, is going to be denoted by the letter Y. This is actual expenditure, not what is planned, but what actually happens. And this is a familiar concept to you. This is gross domestic product, the flow of total actual spending in aggregate on final goods and services. This distinction between what sectors in the economy are planning in terms of their expenditure and what actually happens in terms of expenditure, the difference between planned aggregate expenditure and aggregate expenditure, is absolutely fundamental to this basic Keynesian model. And like planned aggregate expenditure, we're going to think also about aggregate expenditure in terms of sectors, in the same sectors: households, firms, the government, and the foreign sector. And now the concept, short-run macroeconomic equilibrium. It's so important to realise that this is, in one sense, a different concept of equilibrium to what we have seen previously. Previously, we thought about equilibrium as being prices adjusting to secure coordinated decision-making between consumers and producers, or between households and firms, we would say in this instance. But that is not a concept of equilibrium that's terribly useful at the macroeconomic level, at least not in this framework that we're developing here, because we've ruled out prices being able to coordinate decision making, because we're operating at this short run time interval in which prices are fixed. And so we need a different way of thinking about what we mean by an equilibrium. Remember, in very, very general terms, an equilibrium is when the economy is at rest. But what would that look like in a macroeconomic context? Well, we're going to define equilibrium to be a situation where all of those spending plans are realised exactly. In other words, what the sectors in the economy are planning to spend turns out to be exactly what is spent. Now remember that expenditure, spending is a flow, so we're always talking about what's happening over a particular period of time. So a macroeconomy is in equilibrium over a particular period of time if it turns out over that time period that all of the spending plans are realised exactly. So the notation we can use for that is that it's a situation where planned aggregate expenditure equals aggregate expenditure, or PAE equals Y. Now, an economy need not be in equilibrium, so what would a short-run macroeconomic disequilibrium look like? Well, not too surprisingly, it's any situation that occurs that doesn't meet our definition of equilibrium. So it's a situation in which all spending plans are not realised exactly. So there are some sectors in the economy whose plans don't come exactly to fruition, where planned spending doesn't necessarily equal actual spending over the time period we're talking about. For example, you can think of a situation where the economy's planned aggregate expenditure over this time period exceeds actual expenditure. Now remember that actual expenditure, GDP, is the same as actual production or actual income. And that's what we know from the definition of GDP. So when we write an expression that PAE is greater than Y, one way of interpreting that is we're looking at a situation where the economy's planned aggregate expenditure exceeds, over this time period, the flow of output that is actually produced. Put simply, there's a lot of planned spending in this economy and production has not occurred at a flow that will meet all of that planned aggregate expenditure. In such a circumstance, what we usually find is firms will dip into their inventories of previous unsold stock. But this was unexpected. Firms didn't expect this to happen. Firms were expecting that what they produced is what they would sell. In fact, firms discover to their surprise that they're able to sell a great deal more, and so they have to dip into their stock of unsold inventories in order to meet that demand. But this was unexpected. This was unexpected. So we're dealing here with a situation where firms, to their surprise, have had to decrease their inventory stock in order to meet this higher than expected planned aggregate expenditure. can go the other way, of course. Over a particular period of time, the economy's planned aggregate expenditure may fall short of actual GDP. Firms have produced that much GDP expecting to be able to sell it. They find to their surprise that there's less planned spending in the economy than they had thought, and so firms unexpectedly find themselves with unsold stock, and therefore they unexpectedly increase their inventories. This unexpected changes to inventories, as you'll see, is going to be a very important part of this macroeconomic model that we're building. So you can see how the concept of equilibrium here really is a story about the extent to which spending plans match what actually happens. And if the economy is in a situation where spending plans are realised exactly so that the economy produces a flow of output that exactly matches what the economy is planning for its expenditure, that is going to be a situation of equilibrium. Anything else we will associate with macroeconomic disequilibrium. So let's put a little bit more structure on this, and this may take a little bit of getting used to, but it's very important that you understand what it is I've written down here. So we're talking about flows, as always. So over any particular time period, we know the following. By definition, given the nature of GDP, it must be the case that actual output equals aggregate expenditure. We know that from the very concept of GDP itself. Actual expenditure can be divided into two components. One component relates to planned expenditure. But planned expenditure need not equal actual expenditure, as we saw on the previous slide. The difference between the two is going to be reflected in unexpected changes to inventories. Now, I would ask you to think back to our material on GDP. Remember that expenditure on inventories, or changes in inventories, are counted as part of firms' investment. We use the letter I as our notation for investment. Remember the idea that firms are treated as if they purchase their own unsold stock. So unexpected changes to inventories represent unexpected expenditure. So unexpected expenditure which is being undertaken by firms, it therefore can be thought of as being unexpected, and I'll put a little U there, unexpected investment. So to repeat, what we're saying in this line here is that from the very nature of gross domestic product, it must be the case that over a particular time period, the flow of GDP corresponds to the flow of aggregate expenditure. Aggregate expenditure itself can be divided into two components. One, a component that's planned aggregate expenditure, and secondly, an unexpected component which occurs should planned aggregate expenditure and output differ for whatever reason. That shows up as unexpected inventory changes. That can be thought of as unexpected investment. So let's write all of this in symbols. Here, let's start at the right, is our unexpected investment. Everything else in that line represents a component of planned aggregate expenditure. So we have C with the superscript D standing for household consumption of domestically produced goods and services. I with the superscript P represents firms' planned investment. Now that's important. What we're saying here is firms have two different types of investment. one component which is planned, but then they might be caught by surprise and they have this unplanned component. And then we have government expenditure, G, and then we have expenditure by foreign residents on exports, which we represent by X. Note that what we're assuming here, and this is an assumption we're going to carry throughout all of this analysis, that this issue of actual expenditure being different from what was planned relates only to firms. We're going to work on the assumption that households, government and foreigners always have their plans realised. So that the only sector in the economy for which this isn't true is going to be the firm sector, and the sense in which that is not true for firms relates to the possibility that there is unexpected inventory changes caused by production and planned aggregate expenditure not necessarily being aligned.